It's wonderful to see you all joining us, and I still see there are people joining the Zoom. But good morning to all of you. I'm Robert Dijkgraaf. I'm the director of the Institute for Advanced Study, and it's a pleasure to welcome you to this family science talk. Those of you who have been before at IAS know that we typically serve donuts for these kind of talks, but this time, of course, we are all online. But I hope to see you soon back on campus, and then we promise to have extra donuts to make up for this time. It's a very I think we planned a really fun talk to you today. Our speaker is Rich Schwartz. He's the Chancellor's Professor of Mathematics at Brown University, and currently he is a member at the Institute, so he's visiting us for the year with his family in the School of Mathematics. And Rich is, he's a very fancy mathematician. He works on very, very complicated issues, geometry, topology, but he is also, a wonderful author and speaker about mathematics to families, to children. And he wrote some absolutely wonderful books that we will see part of it. He wrote a book, Really Big Numbers, which was actually featured in his first family science talk he gave here at the Institute in 2015. Just won a prize, the MSRI Methical Book Prize. I just read from a review. The book is a masterpiece, starting with small, easily observable numbers, building up to dizzyingly huge ones towards infinity itself. A fascinating journey of discovery, increasingly complex concepts. Today, he will actually lecture from his next book, Life on the Infinite Farm. And I actually have one of his wonderful illustrations behind me. He will introduce us to the residents of this infinite farm. And we will get to know them. It was published with equally raving reviews, with the wonderful illustrations, the fun animals. People really loved it. And it's important that, Rich is not only a wonderful mathematician and a good storyteller, but he also makes these illustrations himself, which is actually kind of marvelous. And I read, Rich, at some point you were questioned, how do you combine the math and the art? And Rich said he thinks of science as art as the two main branches of human creativity, with science to be more controlled and powerful, and art being more whimsical and wild. I love that. And he thinks of his own work somehow halfway between the subjects. So I think we're making ready for a talk that is both, scientific, but also whimsical. And so it will be partly crazy and partly really serious mathematics. So I think it's an ideal subject for this family talk. And also, as those of you who tuned in early know that Rich actually wants to make it interactive. So I said we'll have many opportunities for the children to ask questions, etc. But we also don't want to derail Rich. So it will be a little bit of an experiment. We will try to be halfway between chaos and a very controlled lecture. But I just want to say again, Rich, how wonderful it is to have you with us. I would say live on the Institute campus, and but on the screen. And the screen is yours.
Okay, great. Thanks. Okay, well, welcome everybody. So I want to say two things first. If my computer dies, if it goes blank or I freeze, I'm going to turn around and use my laptop. So this has happened before. I just want to let you know that this could happen. The second thing I want to say is you should, if you want, I'm going to have you guys draw some stuff and have some fun drawing. So I'm not just lecturing the whole time. So you might want to grab a pen or pencil and piece of paper to draw some things. So now I'm going to try to draw this. Well, in a minute, I'll share the screen. I wanted to say first why I wrote this book. I think it's probably my favorite of the books I've written. And when I was a little kid, maybe like 4 or 5, 6, I really used to think about what it was like if things would go on forever. Like if you think about your finger, it just goes for a little while and then it stops. And I would think, well, what if it was a little bit longer? What if it was a little bit longer still? And, what if my finger just went all the way forever and it kind of shot off the planet and into another galaxy? And then I wondered, what about my nose? Well, what if my nose sort of went forever? And, I remember thinking about all those kinds of things. And, what would happen if the walls would expand in the house and they would just keep getting bigger and bigger, and those kinds of things. And I guess I'd say I became a mathematician because I just never stopped thinking about those kinds of things. Like I always liked thinking about shapes, and that's really what infinity is, what infinite things are. They're things that just kind of go on forever. So later in life, when I was an adult, I got the idea, maybe I'll write a book about animals that go on forever and the problems they face and what happens to them. So I'm going to share the screen, and then I'm going to show what I did was I took some of the pictures out of the book. So they're not all the pictures in the book, but I'm going to show you some of them, and I'm going to focus on one of the animals, which is Gracie the cow. And I love cows. So let me just go back to the beginning. So now you're seeing a bunch of pictures. So that's Gracie the cow, and she loves shoes. That's her main thing. She loves shoes. She's got all different kinds of shoes, and she's got one on every foot. Some of them are roller skates, different kinds of shoes. And then the infinite thing about her is that her feet go on forever. They just, if you look at this picture, they kind of go back into the corner, and you just have to imagine them going on and on and on. She's got, the feet just never stop. So the first question I want to ask you guys is, do you think Gracie has a tail? What do you guys think? Does anyone want to answer yes or no?
No.
No. That's
Yeah.
like, yeah? Some of you think yeah? Okay, who thinks yes?
No. I think Gracie has a tail.
Okay, so where would the tail be? Okay, so that's, okay, so here's, so what I want people to do, I want people to draw, to get into it, draw your own infinite animal, draw what it would be like. Maybe you want to draw what an infinite bird looks like, or maybe you want to draw somebody with an infinite hand or an infinite nose or infinite ears. And the one other suggestion I had beside a bird is, since we're at the Institute for Advanced Study, how about an infinite Albert Einstein? What would Albert Einstein look like if he was infinite? So I'll give you guys a couple of minutes to, just maybe to draw, and maybe while you're drawing, I'll open up a window, and I'll draw a little bit myself and show you the program I used to draw the pictures in the book. Let me.
That's exactly what I was gonna do.
You were gonna do the infinite Albert Einstein?
Yep.
Okay. So let me open this up.
The fins.
So I'm gonna open up a picture here. There's not much in this picture, but one thing you should know about me, which is I never thought I was a good artist at all, and most of the pictures I draw are kind of, they just are these simple pictures, and but I go back and I revise them a lot. I go back. What I mean is I go back and I fix them up later. So so maybe I'll try to draw an infinite ear. So this program is really fun because it lets you draw shapes that you like, and you can recolor them. Oops, that wasn't so good. See, those are the kinds of mistakes I always make. So I'll undo that. So I'll try one more. So you guys can see I'm making a kind of a sort of person with an infinite ear, but this isn't such a great picture. And it would just go on and on and on like that. The ear would just keep getting bigger and bigger. Like this. So can I see some of the pictures that some of you drew?
We haven't finished.
You haven't finished. Okay, let me give you guys another minute. If it's okay, so here's one thing I want to say that's important. If it's an infinite figure, you'll never really finish, but you could sort of get the idea. That's pretty neat. That looks like an infinite kind of caterpillar. Is that what that is, Maxine?
Go ahead.
It's actually an infinite person.
Oh, I see.
On and on and on.
It just goes on. It's sort of a head, and then the body just goes down and down and down and down. So the kinds of things I like to think about where, ooh, that's neat. That's like a cow that's going off the earth.
Here's one.
Ooh, what's that? Looks like a fish with an infinite tail.
Infinite arm. I made an infinite snake with
ooh,
an infinite
it's coiled
tongue.
up. Wow.
And it made an infinite tongue.
Okay, that's okay. Okay, those are great. Ooh, all right. I like all these pictures. Wait, say it again.
This is an infinite dog, but I haven't finished all the legs.
That's right, and you never will. But that's one of the important things about infinity. It continues. Well, let me show you some more pictures now. This is the one I showed. This was the Gracie the cow. And here I just made a kind of a little collection. Here's some of the other animals I made on the farm. So one of them is an infinite gopher, like this, and this one was one of my favorites. These are two infinite chickens. So the chicken has just a body like a regular chicken, but then sort of the head keeps going and the eyes sort of go out. So I thought, what would you do if you had two infinite chickens? And the only thing they could really do is stare at each other. So you have to imagine this is like a road. And if you're walking down the road, you'd see all the chickens. And I want to ask you, do you guys notice anything funny about these chickens besides them being infinite? Anything that they probably shouldn't have?
They have a lot of eyes. Big teeth. And lots of teeth.
Teeth. Well, eyes and teeth. So chickens definitely have eyes, but one funny thing that after I do the book, somebody told me that chickens don't have teeth. So this is a little bit embarrassing, but then I just decided that on the infinite farm, they have teeth. Here's an owl. It has a kind of infinite eye. I'm going to talk a little bit about this kind of thing later, but this kind of eye is a little bit like a black hole. Oh, yeah, sure. What's the question?
How would the cow have a beginning if it was infinite?
It doesn't have a beginning. It just keeps going.
It has a head.
It has a head, and that's a beginning, and then it goes up. It doesn't have an end. It kind of has a beginning and no end.
Okay.
So a lot of them are like that. They have this one, like the gopher here has a beginning and no end. And I made a lot of the animals like that because suppose they didn't have a front end, then where would their head be?
Just like the cow, is it kind of like a ray? Like it has a
start
point and then it never ends?
Exactly. In mathematics, there's a thing, it's like half of a line. It starts and then it goes in one direction, and that's what people call a ray. So the cow, it's exactly like a ray, but it's not going to be, I'm going to show you a little bit more pictures of the cow. I'm going to draw Gracie in a different way, and you'll see more of what she looks like.
The gopher there must be no more gophers
in that one hole since the gopher takes up all the room?
That's an excellent question. Maybe, but maybe it's kind of three-dimensional. And so there's one that kind of goes in front of it and maybe even coils around it. So
Yeah, that has to be a thin gopher.
It's kind of a thin gopher. So this was actually one of the main questions I was interested in, is how the animals get around each other. So let's ask a question like that. So here was a question I put in the book. I didn't need to ask this with you guys in the audience, but do you think that Gracie could swing all the way around like a clock? Like, what I mean is she stands still and then she just kind of goes like this. Do you think she could do that?
Not really.
What do you think would go wrong?
Yeah. Because that'd be wrong, because she's not a clock. She can just
I don't think she can.
It would probably
She's not a clock, but what I meant to show is like, imagine like she just kind of rotates around. I'd have to do this, like if you got down on the floor like this, you could kind of go, like keeping your head still, you could make your legs go all the way around. That's what I was getting at.
So you probably hit a building if you had that.
That's right. She hit a building. Even people, like if you're carrying sometimes like maybe I'm carrying a table into the house. You may have seen your parents do this. And if they turn a little bit, they could easily hit the wall or poke out a window or something. So Gracie is an infinite. She's infinitely long. And so this kind of thing could happen. So here's the thing I'm going to show you. This is how I imagine it. No, she gets stuck on the trees.
Yeah.
So I imagine that she's very flexible. And I actually thought that some of you guys might, this is one of my favorite pictures to draw. And I'll where you have some trees and then you have some kind of like a Gracie animal kind of curling around it. And I like how you could think about how can it get caught on the trees. Like it could make a really big spiral and then spiral out and things like that. So I'll show you, I'll try to open up a window and I'll show you what you could do. And maybe I'll have you guys try to make one. So first I'm going to get rid of everything on the screen. And then what I'll do is I'll draw some trees, which these aren't really trees. This is what a tree might look like if you were looking down on it. And then I'm going to show you, you can kind of go around the tree like this. Let me just make the lines better. Okay, you guys see it now? There we go. So
I know what something infinited was actually infinited in real life.
What's that?
Numbers never end.
Numbers never. That's right. This is it's a lot like numbers. So here's Gracie's head, like that, and then her tail just kind of, I'll maybe make it look like an arrow. So let's see. Okay, I'm having trouble drawing a little arrow for Gracie. There we go. So do you think she's kind of stuck on the trees? Because if she tries to pull out, she's going to get stuck on this one. So can anyone draw me a picture of Gracie? How you imagine she might get stuck on the trees?
Trees.
Yeah. So you draw. Anyway, these are my favorite. Try to make it as crazy as possible, like how she's really, really tangled up in the trees. That's the thing. There's actually something in math that people like to study this kind of thing about. They call it curves on surfaces, and this is one of the things I like to study in my own research. Let's see if anyone can I see a picture? Can someone hold one up?
Okay.
Ooh, that's pretty complicated. Let's see. That one's a little faint. I can't quite see. But I really like the challenge is to make her get really, really tangled up around the trees, but not crash into herself. Like one part of her body shouldn't kind of like go over another part. So I'll let you guys think about that one.
She's trying to climb a tree instead.
Oh, she could try to climb a tree. That's true. You know, she could do, like if she was like an inchworm, she could kind of lift up her belly and like get over the tree. But what if the trees were also infinite? Like what if they went up forever too? Then,
Well, then you have to go all back. And then
you have to go, oh, that's a great answer. That's a great answer. Gracie,
Yeah.
she can back up. That's how does she get around trees? What she can do is she can back up and then she can kind of move her head and go forward. So it's a little bit funny. That's a great.
If she was an inchworm, then she would be an infinite inchworm and get over it.
That's true. She could be like an inchworm and like lift up her, do like a sit up kind of, and or not a sit up, but like a, what's it called? A
Push up.
like a push up.
She's back in.
Yeah, bridge pose. In yoga, they call it bridge pose, where you kind of stick your back up, and she could stick her back up. Okay, so all right, so let me ask another. Here's another question about this. And here, this picture isn't exactly in the book, but I decided that the picture in the book looked a lot like the Institute for Advanced Study. This pond here looks a little bit like the pond you'd see on the campus of the Institute. And I was imagining, and here's the sign that you see all over the Institute. Please keep 1.043 Einsteins apart. So this is not an infinite Einstein, but I added some arms and legs to it. So I'd imagine the animals kind of, they're going around the Institute, and but how do they get around each other? Like the Gracie here is getting stuck in front of this other animal, and then the zebra can't get to the pond. It looks like it's blocked. So this was the question that came up before with the gophers. Like, what if there's several? How do they move around?
well, maybe.
So what do you think?
Maybe Gracie could back up, then go behind. Well, then go back around where the zebra is. Then the zebra could get through.
That's a good. That looks like it would work in this picture.
Or they could just go straight each way, and then each animal could get its own way to drink.
They could. I think what you're saying is you could imagine they all are coming into the pond like spikes, kind of.
Yeah.
So each one kind of makes a very narrow. But that's a really good idea. But imagine they were stuck in the trees.
That'd be crazy.
Then it would be kind of crazy. Like maybe they're winding around these trees, and the trees go on forever, and they're so or maybe there's an animal with two sides.
Maybe they can just wait for a person to come. They can also kind of bring off. They say, okay, they'll just cut down a bit of the tree, so then they can just escape the tree.
Okay, they could try to cut down the trees, but then there's infinitely many trees, so they might run out of time. Okay, well, let me. So anyway, I was interested in this question. In fact, this was the main. This was the main thing I wanted to know, and so here's some answers that I thought of.
Be able to touch them.
So here's one answer. Like they could. Here's her cousin, and I named this cousin Boopus, and they can kind of roll over each other. So that's one thing they could do, is they could kind of roll over each other. And then the other thing is I thought of is that they might be at very different sizes. Like I decided this is really, I didn't show the chicken and the cow together, but maybe the chicken is much larger than the cow, and the cow just kind of goes underneath and they don't even interact. So it might be like a multi-scale kind of farm where they're all infinite, but some of them are still bigger than others. And so they kind of can move around. It's the same way like with the bugs. We don't really interact so much with the bugs. They're kind of crawling around, and mostly we don't notice them. And certainly like with microorganisms, we don't really notice them unless they make us sick. So I was imagining, and maybe there's really huge beings in the world, in the universe, and they're so big they think of us just like like bugs or something. But anyway, this is one idea I had. And then the other idea I had was sort of a funny one, that the animals had sort of funny. So this is a shark with an infinite head in 2 directions. And this thing is like an infinite octopus. And, you know, if they're swimming around, the octopus is going to get
the octopus.
So the shark kind of, his head has a trap door, and then the octopus can kind of slide through.
What happens to the other part of the octopus? And what happens to the other part of the shark then that got unhooked?
Well, you know, that's a really good question. You might worry it kind of drifts off. So I had the idea that they had magnets, you know, so magnets kind of held it about the right. So, you know, so the trap door opens up, the squid arm passes, the octopus arm passes through, and then it kind of closes back up. And so, you know, we humans have a lot of adaptations, like eyelids. You know, we don't like the sun in our eyes, and so we've got these funny flaps that come down and close. And I'd imagine that the animals also sort of have these funny adaptations. Their main problem is getting around. So, okay, so those are some questions. So now I'm going to talk about another. Gracie has a problem with her shoes. So this is, I'm going to explain a problem and then ask you about how she might solve it. And this problem will give you sort of a feeling for the nature of infinity. So she loves shoes. I already told you that. And she's got shoes on every feet, but then sometimes her friends bring her new shoes. And she wants to wear the new shoes, but she doesn't want to give up the old shoes. She doesn't want to take off the other shoes. So suppose that happened to you. Suppose you've got your favorite pair of shoes and somebody gives you a new pair of shoes. What do you do? What would you do?
How is she supposed to take off?
It didn't happen to me.
It happened to you.
Because isn't she infinite?
So
Because she's infinite, so she could just take it
yeah.
and just run. Then she could just run to the spot that she
No way.
hasn't opened.
She could, that's an interesting idea. She could take it and she could run. So I'm not sure if that's gonna exactly what that would do. So but well, what I would do is I'd probably wear one of one shoe and one of the other. But you know, just like I'd wear like a red shoe and a blue shoe. But that's a kind of a strange thing to do. But okay, so
Take off her shoes.
she could take off her shoes, but she could take off her shoes, but she doesn't.
Infinite legs.
She's the thing about Gracie is she's very she's sort of a greedy kind of a cow. She loves presents and she doesn't want to give any of them up.
Oh.
So it's kind of a puzzle. What can she do?
To be
Right.
about the cow of her.
She could move the shoe back.
Oh, move the
Close
shoe
you
back.
Backward.
Starman, that's a great idea. Okay,
She
so
has
showing her
infinite
rear.
legs. So why does she
ooh, I like that idea. So let's
on?
okay. So let's go with Styron's idea and let's see where that goes. So
I think it's weird when you do.
okay, so here's what she's gonna do. Okay, this is just more of her problem. She wants to wear the new shoes, but she doesn't want to take off any of the old ones. So here's what she does. This red thing is like sticky tape. If you stand on it like this, the shoes will stick to it.
And then she's just gonna step into the next.
So she puts the shoes. She stands on the shoes and she puts the new ones in front of her. And then what she does is she steps. I kind of drew this a little bit slowly, but she's gonna step out of the shoe, and then she steps into the run in front of it. So now,
Yeah.
so now that all the shoes, imagine the shoes are all kind of stuck to the tape and all the legs just kind of move forward. And now every shoe is still being worn. So she's still missing a shoe, but now she just does the same thing with the other side. And now she's got all the shoes. And you might worry, what about the back end? But she doesn't have a back end. The legs go on forever. So she just has another, she's wearing all the shoes now. And so she used her infinite property to sort of solve a problem that an animal like, someone like you or me couldn't do. In math terms, you might say infinity plus 1 is infinity. That's a very loose way of saying it, but
Infinity and 1.
But somehow, so infinity, if you treat it as a number, it's a little bit funny. It's not like if you take 5 and you add 1, you get 6, which is more. But somehow,
Of everything.
So I want to say some of my intuition for this. Like, if you take 1 and you add 1, you get 2. That's twice as many, which is a lot more. Like, imagine you were eating one bowl of ice cream, and then they said, well, now you can have 2 bowls of ice cream. That would be a big change. But imagine you were eating like 4 billion bowls of ice cream, and they said, well, you're eating 4 billion and 1 bowls of ice cream now. You might say, well, it's not really that different. It's basically the same thing. And it's the same thing here, like sort of for very large numbers, if you add 1, you could sort of argue that it doesn't really change very much. And so if you kind of have an infinite number and you add 1, it doesn't change at all. That's a little bit how I think about it. So I also, okay, then of course, Gracie, she moves off the tape, and then she gets another present and she repeats it. The only funny thing about this is that
what happens if infinity is multiplied by infinity?
You can, okay, so let's talk about that next. I won't quite do that, but I'll talk about infinity times 10. Let's talk about infinity times 10. That's a little bit, so here's another animal.
You guys are not muted.
Another animal is Hammerwood. So Hammerwood, he's an infinite crocodile, but you can't really tell right now. So let's zoom out.
Whoa.
So this is what he looks like. Hammerwood has 2 main features. I'd say one feature is that he's got infinitely many teeth, and the other feature is that he loves bubble gum.
It looked like a tomato for a second.
You thought it was a tomato.
Well, yeah.
Yeah. This does look a little bit like a tomato. But well, I think it also looks like bubble gum.
Yeah.
And the things behind him sort of look like tomatoes too, but I was imagining them as being like red rocks. And I was imagining the sky as being
It was
purple.
because your mouse was green and it was on a tomato, like the top of a tomato.
Uh-huh.
A circle, bubble, like a perfectly circle
Uh-huh.
one. So it looked like a tomato.
Yeah, that's pretty funny. This is well, this is what I thought bubblegum looked like. I tried to make these like shiny things here to make it look like they were shiny. And some of the other bubbles, which I'm not going to show, I drew a much more complicated one. But anyway, he loves bubbles. That's his favorite thing. But then there's an issue, which is that he doesn't. Whoa! I want to say one thing. How does he chew the bubbles? So imagine do you think, like, how do you chew bubbles? Like,
This whole thing would open up and then.
right, so imagine the whole thing opens up, but then maybe like if there was a bird flying above, boom, he'd hit the bird and the bird would fly off, and imagine there was like, he was under a bridge. I mean, if he opens his mouth to chew, like, if you think about it, like this is sort of like the lever principle. If you open up your arms, as the further out they go, the wider they are. So think about how fast his mouth is moving if he opens it up.
The end of it.
Like, you open it up and like
All of it closed and
it's going like a million miles an hour, a million feet out or something, a million miles out, and then like a billion feet out, it's going like a billion miles an hour.
No, he can keep part of it.
So like
This part of it
Wait.
closed and chew the gum,
so
and the other parts
the idea.
that were open.
So I thought it was, the idea I got was maybe he kind of grinds his teeth, like it kind of opens up, like almost like his mouth does like push-ups, like they kind of go and every so often his mouth kind of opens up. Let me try to draw a picture of what I mean. I sort of was imagining.
If they were infinite, they wouldn't have to walk anywhere because they would just be all around the world because they're infinite.
That's true. Although they might not even be in the world, because they might just kind of. So here's what I'm imagining what his mouth looks like, sort of. Sort of like that, and then the gum kind of goes, oops. Nope. The gum kind of fits in here. So that's kind of how I was imagining his mouth. It kind of goes, you know, he's got like a kind of flexible muscles in his mouth. So anyway, that's I have to draw his head. This doesn't look very much like a. That's kind of what he looks like, a little bit. All of you guys should be encouraged because the pictures in the book ended up coming out pretty nice, but this is really about how well I can draw. So what I'll do is I'll draw a really bad picture and then I'll kind of gradually fix it up. Like you can do fun things, like you can sort of like, you know, make some curves, and you know, you can do all kinds of, you can take the picture and maybe you can make them green. If you don't like green, you can make them pink. So you can sort of start, you know, then you can do neat stuff. You can make them all kind of rounded like that. And you can make this rounded. So that's kind of how I imagine his mouth.
Now the head looks like an octopus, except with only
It kind of looks like an octopus. That's right. Maybe he has an eye, white eye. So that doesn't look much like, but this is kind of what I'm imagining the thing, what Hammerwood looks like. But of course, I need to fix up the picture. Anyway, this, if any of you are curious, this is how I drew the pictures in the book. I used this drawing program, which is called Inkscape. Okay, so all right, so anyway, I haven't said what his main problem is. His main problem is that he never brushes his teeth. So this is the one lesson in this lecture. Remember to brush your teeth. So this is what it looks like up close after a while. He doesn't brush his teeth, and then this is sort of what it looks like after a long time. Just bad things happen to his teeth, and it gets so bad that well, he loses most of his teeth. They just fall out. And so imagine most of your teeth fell out, and you wanted to have a full set of teeth. What would you do? What would you do if half your teeth fell out?
Brush your teeth.
Brush your teeth. Well, it's too late. Half your teeth already fell out.
Well, you can make plastic things that connect onto your teeth. So they just act like plain old teeth, but they're...
Oh, that's a good point. That's right. That's true. You can get things like that, like dentures or dental implants. But
well,
imagine he doesn't have that. He has to use... So here's
maybe he can find his old teeth, and
he can find his old teeth, and
then he can glue them on with.
Oh, that's an interesting idea. That's a good solution. But imagine these teeth they're really rotted. They've just become you know, it's really bad. So they're not only do they fall out, but they fell out and they don't look good. It's like I said, it's not pretty. So the puzzle is he just has to use the teeth he has. So
if he was infinite, he'd have infinite teeth.
He does have infinite teeth. So Jack, that's a great idea. So let's build on that. So here's what he's going to do. Well, this is a kind of a cartoon. So the first thing he does is he brushes his teeth. And then ants come. There's an infinite supply of ants. This is sort of, how many of you have heard of braces? So braces is this thing they put them on your teeth and they straighten your teeth. So this is something like braces except less professional. And what happens is the ants, they put the rubber bands around his teeth, and each rubber band kind of links two of the teeth. And then they finally, like, the last thing they do is there's a stick here, and they kind of anchor the last rubber bands onto the stick. And then what happens at night is that all the rubber bands contract. So what's going to happen when the rubber bands kind of come together? What's it going to do to the teeth?
The teeth like come closer together.
Exactly. So
Then it'll have more mouth open, like with no teeth.
Well, no, because the mouth goes on forever, and so do the teeth. So the teeth are all just kind of sliding into place, no matter where he is on the mouth. So somehow the idea is that what's weird about this is that he starts out with teeth, and afterwards, in a sense, he has 10 times as many, but he hasn't really added any teeth. It's like he's just sort of taken the ones he has and he's sort of slid them in. He's repositioned them. So this is sort of like a little bit of a demonstration that infinity divided by 10 is still infinity. You divide by 10, it's like you're taking out all the teeth except for every 10th one. And then you somehow go like this. And it's maybe my intuition for this is the same kind of thing. If you had like, one scoop of ice cream and then someone gave you 10, this would be a big difference, but if you had like a trillion scoops of ice cream, this, something just like going off up into the space, and then someone made it 10 times as much, you might think, well, what's the difference? I mean, I can't even see the end of it anyway. So,
wouldn't he bite the rubber band?
Wouldn't he bite the rubber bands? Well, he's got a lot of practice. So I guess what I would say is that the first time this happened, he had all kinds of mishaps happen. But now.
Yeah, but then how would the ants get all the teeth? Isn't it infinite? So like,
that's
how
right,
would
but
they
there's
get
an infinite
all?
number of ants.
It takes so
Yeah.
long.
So the ants kind of, I'm imagining that the ants are kind of coming from everywhere. Like they just kind of fan out, and they kind of reach his mouth at all different parts, and then they do their job, and then they sort of go away. So the ant colony is sort of like another one of these infinite stretching rays, you would say. The ants there are infinitely many ants, and they're kind of everywhere. So I just have a couple more slides, and then I'll finish, and just maybe I'll ask, answer any more questions you guys might have. So the last question that people might ask is like, can you visit the infinite farm? Like where is it? Like, do you think it could be on Earth? Like, what do you guys think? Yes or no?
No.
Probably not.
If the farm was infinite, then how would it fit on the Earth?
How would it fit on the Earth?
Yeah,
That's an excellent question. Right, Gracie would just kind of stick off the end, and she'd go, past Mars and Jupiter, Saturn, etc. Into the Andromeda galaxy and so on and so forth. But
It would not fit.
it would not fit. But here's an interesting idea that I want to tell you about. Imagine you have a fishbowl, okay, and it's got magic properties. So picture a big fishbowl, like a round fishbowl, and we're looking at it from the outside. But inside the fishbowl, the space is warped. It has a special property that as the fish swim towards the edge, they shrink, or they seem to shrink to us. So what happens to a fish is it's swimming towards the edge. It starts going, and it starts getting smaller and smaller to us. It doesn't think it's shrinking because it's in this magical water. And so there's no edge for the fish. It just kind of goes on forever. It would swim forever without hitting the end. And so the inside, there's a notion of like what they call curved space or warped space. And it's the kind of space that you see inside a black hole. And so the idea is that you could have one of these kind of fish bowls, which it's sort of, people call it hyperbolic space, or sometimes they call it non-Euclidean space. And you could imagine one of these fish bowls just sitting on the Earth. So I would have to say the answer is yes and no, because maybe like what would happen if we had a big black hole on the Earth? Would you guys be happy with that or unhappy? Would you like to see one up close?
I'd be unhappy because you'd probably get sucked in forever.
Exactly.
Yeah, I agree. I definitely agree.
Yeah. So even though it would be really amazing to see a black hole up close, it would not be a good idea until we have better technology. So anyway, if you really had one of these kind of like black hole fishbowl things on the Earth, it might just suck the whole Earth into it and just destroy the solar system. So
I've heard that the black hole is way too massive that anything that goes in it gets shredded to parts.
That's right. That's why you wouldn't want one of these things. The other thing, if any of you gets really but what I'm trying to say is that mathematicians do study these kind of infinite spaces, which somehow from the outside look like they're just enclosed in a ball. And so you could imagine the farm was in one of those things, and then it's sort of infinite from the inside. So I was picturing something like that. But anyway, I think the short answer is you can't really visit the farm. It's just a kind of an ideal thing in our minds. And so then the way I answer this is that this thing I was drawing, I was sort of imagining actually I was at a place like the Institute for Advanced Study, which is sort of it's a beautiful building. It's got a great library. It's got a lot of books. And there I am standing around at it. Although I would probably just be wearing a t-shirt. But anyway.
Everything in the universe was infinite.
Everything in the universe was infinite. Well, let's talk about that in a minute. So anyway, the last thing I want to say about this is that the thing that inspired me for the books was for this book was like things I learned about space from reading geometry books. And so that's the end of the book. If you read geometry books, you might find it. And this particular book is my friend Martin Bridson wrote this book, and I put it on the cover just to make him amused. So some of these books, like the Geometry and Topology of Three Manifolds. This is a famous book by my advisor, Bill Thurston. I was a student here at Princeton many years ago, and the guy who wrote this book was my advisor. And then I put in the proceedings of the Flat Earth Society, because, the farm, you can think of it, it's a little bit like a flat Earth. And then the Hilbert Hotel is sort of like this idea about Gracie putting on a new pair of shoes by stepping into it. Some mathematicians call this the Hilbert Hotel. And then I've got a lot of other books that are somehow, I thought were related to this. So all of these other books kind of inspired this one, and also just my thinking about space when I was a kid.
Even the Cat in the Hat Comes Back.
The Cat in the Hat Comes Back. Have you read that book? Have you seen it? That's a great book. What happens is there's a spot that the cat makes, and he has to clean it up. But let me stop the share and answer. So the Cat in the Hat Comes Back. The cat has a spot he has to clean up, and he can't clean it up. There's too much of it for him. So he kind of opens up his hat, and then he has a helper cat, and then the helper cat sort of starts trying to clean up. But in fact, all that helper cat does is make a bigger mess. And then the helper cat opens up her hat, and there's another cat, and then that cat, and so on. And the cat keeps. You start seeing that really there's probably an infinite number of cats and hats. But then something really weird happens when they get to cat Z. I think it goes boom, and it just sort of removes the spot. So So I thought that somebody, my friend told me that there's something in math that's called a capped grope, and that this is really what this is describing. So any of you, some of you mathematicians who are four-manifold topologists might have heard of a capped grope. But, anyway,
my dad has said that gravity isn't actually the strongest.
Oops, I can't. I lost the sound. So I didn't hear that last question about gravity.
He's muted.
He's muted, but I might not have known the answer. So, so do you guys have any other questions?
If the universe ends, can you go through it?
That's an excellent question. People, lots of people have wondered about that question, and I used to wonder about that too. So let me give you an answer that I think is interesting. Imagine you're in your room, and imagine there was a magic feature of your room that if you went out the left wall, you would pop back in the right. And imagine like if you went through the front wall, you'd pop back in through the back. And if you went through the ceiling, you'd pop back through the floor. So you wouldn't even notice that there were any, this thing is what I just described is what's called a torus. And if you, some of you may have played video games, like how many of you have played Pac-Man? And how about Asteroids? These are all games I liked when I was a kid. But in these games, you go out the wall and you come back in the other side. And so really, there's no wall at all to the room with the walls, so to speak, identified. You go through and you just pop in. Even in the corner, you don't notice that there's any walls or edges. So this is an example of it's a finite space. You could completely fill it up with bowling balls, let's say. But you could move around forever and you'd never see an edge. And you'd just be trapped inside of it. So, when people say that our universe is finite, that's one idea that they have, that our universe is kind of like that thing. It's like it kind of wraps around, and you never get outside of it. You never see an edge. Yeah, question? Maxine?
Yes. If the Earth was infinite, how big would the continents, the states, and the towns be?
If the Earth was infinite, well, that's a really interesting question because
Earth is infinite.
No.
Well, you probably mean like an infinite landmass, right? Like it goes on. You want to know, like, suppose it goes on forever, right? So there are different possibilities. Like one possibility is that that the continents are just like they are. There's 7 of them, and then there's just ocean. That would be one answer, but that's kind of boring, right? But another answer might be that the continents, they're all like the same size of ours, just finite sized, but there's infinitely many.
Some continents can be mountains.
That's right. They could be mountains. They could be islands. So one possibility is that there's just these islands all over the place and they go on forever. Another possibility is that there's, what I like about that possibility is that what I always think is what I'm fascinated by, if there's an infinite universe, well, you'd imagine just by luck, there's another planet that's sort of like Earth. And then there's another one which is even more like Earth. And then there's one which is like really almost exactly like Earth, and there's someone who looks like you on it. And then further out, there's another one that looks like you, and then there's your whole family. The idea is that the chances of things looking exactly like Earth and like you are very, very small. But if you have an infinite opportunity to do it, then these chances will be realized. It's very much like the monkey typing on a typewriter and reproducing the works of Shakespeare. If you let the monkey go long enough, they'll do it, probably. So if you have an infinite Earth, you could sort of probably imagine there's going to be copies of you or almost copies of you all over the place. And then some of them will even have the same day you're having today. And some of them will even have the same week. So anyway, another thing is the continents could be infinite, or there could be both finite and infinite continents. So all kinds of possibilities, I'd say.
Some continents be as big as a boulder?
Well, actually, even our continents are bigger than boulders.
Yes, these two questions.
So I think yeah, I think the answer to that question is definitely yes.
If the Earth was infinite, then wouldn't it go all the way through the universe?
Absolutely. Well, I don't know, a physicist on here maybe could tell me, but
Could a pillow be as big as the Earth?
could a table?
No, a pillow.
A pillow, yeah, why not?
But what if the Earth was infinite and the universe was infinite? Would they be the same size? Or could infinite Earth be smaller than infinite universe?
That's an excellent question. I think the answer to your question is certainly yes. Like imagine the Earth just kind of opened up to the left and the universe opened up both to the left and the right. Or imagine that the Earth was like a line and the universe was like an infinite tabletop. Then the infinite line would only take up a small part of the Earth. The other thing I didn't talk about in this talk, which is even more fascinating, is that I don't have time now, but it turns out that there's more than one size of infinity. Somehow there's actually like there's like the counting numbers.
Like infinity multiplied by 2?
No, it's like this, like the counting numbers, like one, the numbers, the numbers you count, 1, 2, 3, 4, etc. You could compare those to what's called the real numbers, which are just all numbers, like pi is a real number and square root of 3, all these weird numbers, 2/3. And there's actually like a larger infinity number of real numbers than counting numbers. And this was really discovered by a mathematician named George Cantor about 150 years ago. So this is kind of an amazing thing. There's more, like all the kinds of infinities I've been talking about are sort of like the smallest size of infinity, but there's larger infinities and there's not just one larger infinity, there's infinitely many larger infinities. So I'd say it's a pretty weird, math is a pretty weird situation. Yeah.
But if Earth were infinite, it has to go into the void because the universe is still stretching.
Yeah, that's a good point. I mean, there's some time question.
And it hasn't complete.
Void is the other possibility. That's right. The universe might be finite, but
is still stretching. Then what is it stretching into?
Well, okay, it's stretching. It's a little bit. That's a great question. I would say to answer that is that the universe is. I would say it's not actually stretching like a rubber band. It's sort of like the way you measure distances in the universe is stretching at all places. That's maybe the best I could say. Robert might have a better answer.
What is
but it's like
infinity.
It's like the Big Bang. I think it's not like something exploded outward. It's like the way of measuring things happened at all places at the same time. That's about the best I could say. So the universe it's stretching like internally or intrinsically or something. It's almost that's about the best I can say. So I'm not worried about that.
If black holes are infinite, if you went through them infinity, would you just come out the other side of the universe after you got to the end of the universe?
That's a very good question. Some of them are like funnels, and I think they don't end. But then some of them, they have these things called wormholes.
But if the distance are always getting bigger, eventually you'll reach the limit of the universe. Then the universe also needs to get bigger so that the distance which are getting bigger can eventually fit.
Yeah, that's true, but I think it's not like there's an end of the universe. It's sort of like it's like this kind of thing, enclosed space that you're trapped in, and it's just kind of, it's like this magical material that just kind of gets kind of bigger somehow as you go. But that's a hard. I always, I always wonder this. I'm not a physicist, and sometimes when I talk to physicists, they'll say like, this is what there's parallel universes or something, and then I'll say, well, how do you know? And they'll say, well, that's what the equations say. And then I wonder, like, well, I mean, I'm not sure, like, if we really know what really is going on in the universe. It's like we sort of have these equations which predict things. And then we have our own, this is kind of the artistic part in a way, like we have our interpretations for what they might mean, like the universe is stretching or something like this. But so I can't really answer those questions. The physics questions are really hard for me.
But if there's an end of the universe, then what would the universe turn into if it ended?
That's a good question. Well, that's what I think. I think it doesn't end. That there's just nothing else there. There's sort of, like imagine you're living in your house and everything's fine, but there's nothing outside your house. It's just your house. That's sort of what the universe is. It's like your house with nothing else.
I've heard that infinity isn't a number, though.
Well, infinity is kind of a rough term. It means different things to different people.
It's not.
I mean, it's not exactly a number. Some people like you could say that infinity is a name for certain collections of things in the same way that 3 is like a name for 3 chairs or three pumpkins. Infinity is certain size. Infinity is like a kind of a name for certain collections of things, like all the counting numbers together. So you're right. It's not really a number.
Does Dolores have a countable number of tentacles?
Yes. So let me explain that question. What Talia just asked. This countable is another name for the smallest size of infinity. And so the answer is yes. But if you look at all the possible paths through Dolores, I didn't show a picture of Dolores. She's a kind of an octopus or a squid that branches out forever. But if you look at all the possible ways you could go through her tentacles, that's a bigger size of infinity. That's called, they call it Aleph 1, or uncountable.
What is Dolores?
Dolores, she's an infinite squid. Just that goes. Talia has a picture of Dolores. It's like a think about a tree. A tree is like, it's got a branch and it has other branches and other branches. And so Dolores is sort of like a living tree that goes on forever. So technically I would describe her as a rooted binary tree. That's what the math term, she's a living rooted binary tree. That's what she is.
What if something like, if infinity's a countable number, is infinity something you can count up to if nobody stopped counting?
That's a good question.
I would say, before you answer, we'll make that the last question because we've actually gone over our hour. Okay.
Well, let me just answer that quickly. So imagine you counted the numbers, and every time you counted one, you sped up twice as fast. So you took 1 second to say 1, then half a second to say 2, and then a fourth of a second to say 3. So you'd be going blah, 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 towards the end, but after 2 seconds, you'd be done. So you could count them all if you are willing to speed up. Of course, physically you couldn't do that, but theoretically, I don't see why you couldn't count them all by just speeding up.
Well, Rich, I think we reached the point of maximum confusion and learned a lot. So thank you so much for doing this. Before we try to applaud you through the screen, I just want to say that if anybody wants to thank Rich and make a kind of a nice drawing of an infinite animal, just send it to us, or or electronically or by the mail. I think that would be terrific to see some of your drawings. That would be a very nice nice gift actually to Rich. So I thank you so much for doing this. Of course, you can also buy Rich's wonderful books. But thank you for doing this and being so generous with your questions and making this interactive. So
yeah, great
for those
question.
of you who are muted, you can applaud and cheer for Rich.